and it mostly runs on LinOS and PakeOS. LinOS being a Linux operating system, and PakeOS a real-time operating system that can also run as an IP. And I also write a lot of code around binary protocols, decoders and encoders.
Hello everyone, I'm Robinson. I am also developer at La Ruche since 2021. It's my first job after school. I personally mainly write software in Go, but I participated in 3 projects since I'm in La Ruche, and in 2 of them I used Rust. I mainly integrate on Kubernetes, and I started using Rust quite recently in projects that until now only have used Go. So here is a little agenda of our presentation. So first we will tell you about what is La Ruche. Then we'll shortly introduce you why we started using Rust at La Ruche and how. Then how does Rust fit with La Ruche identity? And finally, the key feature we love about Rust and how Rust answered our needs. So first, what is La Ruche? La Ruche is a THALES entity created in 2017. It's based in Rennes, near the DJMI and the ComCyber. In La Ruche, we work mainly in the field of military cyber defense and data sovereignty for air operation. We do what we call co-innovation in cyber defense. So cyber defense, air because it's cyber defense applied to air operation. And we aim at answering the growing sophistication of cyber threats with short and agile development cycle for fast delivery. And users are directly involved in solution design. To be more specific, La Ruche aim is to make data reliable from end to end. So that means from military radar to air traffic control operators. Criminals could target many of the sensitive points that ensure the sovereignty of our airspace, from radar transmission to communication between aircraft, for example. And therefore, our job is to detect or protect these threats. So a little description of the La Ruche philosophy. So a philosophy user-centric. So it's divided in 5 points. First, focus on domain-specific. The code is a mean to an end. What we mean about that is that the developer must not focus on the code, but on the application itself. How to ensure the sovereignty of our airspace and prevent the various threats to it. Time to market, rapidly deliver operational capabilities. So the projects at La Ruche operate on very short delivery cycles compared with the industry standard, with new version delivered roughly every 6 months. Code scalability, adapting to customer needs. So we continually take user feedback into account and adapt our products as quickly as possible, and customers are always in the loop. Produce safe and secure code with native quality. So we provide native quality, and this is why, as we'll see in the presentation, the choice of languages we use in our projects is at the core of our philosophy. And finally, rapid ramp-up, limiting the use of specialized experts. La Ruche is a small entity, but really fast-growing, with many employees fresh out of school. So indeed, La Ruche was created in 2017. It's in the city center of Rennes, with only 7 employees and only 1 team. And then it grew rapidly to become 3 squad in late 2019 with 40 employees in a new building nearer to the DJ and Comcyber, still in Rennes. And now in 2023, we are 92 employees divided in 6 squads. And 2/3 of the employees are less than 30 years old. But most importantly, La Ruche is a very pleasant place to work. We work in large open spaces, which reinforce mutual support within and between teams. The teams are very close-knit and we do a lot of afterworks and so on. Even with the manager and the chefs, we have a close proximity with them. They are also part of our afterworks and so on. But let's go down to business, and I'm gonna let Pierre tell you about the history of Rust use at La Ruche.
Okay, so we will now see why we started using Rust instead of Go for some of our developments. Since the beginning of La Ruche in 2017, Go was the only language we use for backend development. This choice was made around 4 characteristics. Go helps us write more secure code because of its features around memory safety. It has a garbage collector, variable must be initialized, array access are bound checks, and many more. Also, because of how its syntax is easy to read and understand, Go code is easy to review, which improves its security. Another main advantage of using Go is the fact that it's incredibly easy to learn. This is a necessity for a fast-growing entity, as we are at La Ruche. With Go, young developers are ready to contribute to our project in less than a month. In this way, we don't need to find Go experts to continue our goals. Also, with its clear syntax and its rich tooling, Go allows us to develop high-quality software that are easy to review and to maintain. And finally, because it's massively used in cloud applications, we're not scared about its sustainability. Okay, so Go is great, but why are we here? What happened? In 2019, we started working on a new kind of project that was our air military and network security equipment. This equipment being on the critical path of sensitive data, but safety concerns that were higher than our previous project. Data must be dealt with in a stable time with low latency and without interruption. We managed to match the requirements of this project using Go, but it made us realize that we would have to work on projects on the same kind where using Go may be difficult. So to prepare ourselves for our next project, we tried to list what features a new language should have to address our needs. First of all, we need better performances. Go is pretty fast, but by design, it's not well optimized, and we sometimes need to spend time making optimization for small wins. We need to reach lower latency and lower jitter. Also, we would like to have a lower footprint to integrate in less powerful hardware or embedded systems. With its runtime and garbage collector, it's difficult to gain control on the execution flow and memory when we write Go code. We can control when the garbage collector stops the word, so we prefer not having one. Even if Go helps avoiding a lot of errors, it's still pretty easy to run into data arrays, for example. In this example, we see we start 10 tasks with the Go keyword, and we expect them to print from 0 to 9, but in the end, we can't predict what will happen. Because all the tasks share the same variable I. So we will be interested in a language that could prevent this kind of error. And we are also interested in a language that could have been certified, have a certified compiler in the future. And finally, sustainability. We also want a language and ecosystem that was made to that. So the question was how to meet our performance and safety need, but without sacrificing La Ruche identity and the reason from which we made the choice of Go in the beginning. So we started looking on two languages, Ada or Rust. And before making a choice, we took the opportunity of a new study to try using Rust. We were working for a study on a new kind of gateway with another entity of THALES, and we had to provide them a codec for specific binary protocols. The gateway had such requirements that were 10 times higher than what we already work on and 5 times lower latency. Also, the codec will be delivered as a dynamic library for usage in C++ application. This was a good opportunity to try Rust for two reasons. First, because we knew that it would help us improve our performances. Also, Rust is known to make interoperability with other languages easier and more efficient than Go. In the end, we were able to rewrite and improve our codecs in Rust without too much difficulties. Rewriting our code that we already knew helped us focus on learning Rust, and we achieve a better performance without unmade optimization. This study also proves us that it was possible to write Rust in our specific development environment, as we will see later. So we kept playing with Rust for study and tooling until we went to the next step and prepare a main gate on Rust usage. A main gate is a required event before using a new technology at Thales. During this main gate, we demonstrate how Rust addresses our performance and security needs, but it's also an event where we identify the risk of investing in a new language and how these risks are mitigated. The mitigation can come from the language itself, the community, or ourselves. So the first risk was sustainability. As said, the usage of Rust in a wide range of domains, even in Linux and Windows kernel, made us confident that it was not an issue for us. Another risk was stability. We do not want to rewrite our code each time a new compiler comes out. This risk is mitigated by edition systems that Rust provide. About code maintainability, we want to be able to maintain our code base as it grows. Also, using a new language should not lead to change in the other technology we use. And finally, we feared that the cost of learning Rust will be at odds with La Ruche philosophy. But we will see later how the language and tooling compensate for this learning cost.
So the next question that we ask ourselves is, how does Rust fit with La Ruche identity? So first, a little reminder, we are not Rust experts, like we said. La Ruche grew rapidly and the majority of the employees are beginners. So we need a compatible language that can be used by beginners while guaranteeing that our applications are safe and secure. Yes, but Rust is known for being hard to learn. Indeed, it has a syntax more complex than other languages like Go or Python, for example. As an example, here are two code samples taken from Go on the left, Go library on the left, and Rust library on the right. And it's easy to see that the one taken from the Go library is easy to learn, even for a beginner. Whereas the one taken from the Rust library is more complex when you don't know the syntax. And therefore, developers may be afraid to start learning Rust. There are a lot of totally new concepts to learn in Rust, like ownership, borrowing, or lifetime. But Pierre will tell you more about them later and why they are interesting features of Rust. And here, Faster Than Lime, a famous blogger that talked about Rust on the internet, tweeted this beautiful curve that resumes well the learning of Rust and all the new concepts that we have to learn. So indeed, it is hard, but actually, maybe not so much. Because the compiler is really nice. The Rust compiler is really powerful and can avoid a lot of errors. In this little sample of code, we define an enum with two fields, power and responsibility. And as we all know, the first can't come without the other. But then we match on one instance of the enum, but we do not check all the enumerated fields. And while compiling, the compiler strictly refuses to compile and explain clearly the problem. And in other languages, such as Go, the compiler will have remained silent, which could have caused problems later on. But it is also not that hard because Clippy is also there to help you. Cargo Clippy is a collection of links to catch common mistakes and improve your Rust code. And just by writing Cargo Clippy in your terminal, you can at once improve your code quality. Here it suggests you to taking a reference as a parameter of your function as it is not consumed by the function. And also learn about new features of the language and how to use them. Here, instead of a match, it suggests using a let else, and even give you the code. You just have to copy and paste it if you're happy with it. So yeah, you thought it was going to be long and difficult, but in the end, you save time on the bugs you could have had. To summarize, there are a lot of unique concepts, so there is indeed a learning cost, but it's not so complex because you avoid a lot of mistakes. And therefore, it is in fact compatible with a growing team, Rust being safe and robust. Even if you are not an expert, your code should be safe if it compiles. We like to say that there is no illusion of ease with Rust. It's hard, but the tools such as the highly educational compilers and Clippy help you make code that works and code that is safe. On the other hand, for example, with C++, it can make you think that it's easy because it lets you do whatever you want, but it also lets you do things that could have serious consequences later on. Okay, so we can code in Rust, but then what? How does it compile? How does it fit in our stacks? Shall we rebuild everything? Because indeed, our development environment is designed for Go. But in the end, it was very easy to integrate into our development environment, as the basic tools are really similar to what we have in Go. Some example here: Go build and cargo build to build the program, basically. Go test and cargo test to test. Golang CI-lint and cargo Clippy to improve your code quality. And Go PLS and Rust Analyzer, the language server protocols that allows us to use our language smoothly in our favorite IDEs. And talking about IDEs, Rust is of course works well with all the common IDEs like VS Code or IntelliJ, and there are plenty of plugins for using Rust as easily as possible. And it's also integrated well with all our productivity tools like Grafana and Prometheus for the metrics, or SonarQube for our code quality, for example. Okay, so for standard environment, it works well, but we work in a specific domain, the military cyber defense, and thus we have specific needs. Indeed, with our specific constraints, we need an air-gapped environment. This means that we work physically isolated from external networks. So we had to find tools that help us make Rust work seamlessly offline. So here are some of the tools that we use at La Ruche to keep our environment running smoothly despite these constraints. So first, Panamax. It's a tool to mirror the Rust and crates repository for offline usage of cargo. Artifactory from JFrog, that is used to store and manage software package and containers. And Git that is known to be one of the easiest, fastest, and most painless way of setting up a self-hosted Git service. We chose Git also because it has been written in Go, but since recently it can also be used as a cargo package registry. And we also have set up a local Rust app, the Rust toolchain installer, to allow simplified installation and updating of Rust. So therefore, it works smoothly with our already existing CI/CD. Everything is not related to Rust, of course, but I am going to explain you really quickly our whole integration process. So first, we have Jira. We work in Agile Project Management, and we chose Jira as our Agile Project Manager software as it works offline. And then we have our IDEs and Git that we just talked about. Then we have Drone for our automated integration chain. Then, of course, our unit testing, Go test and cargo test. Followed by SonarQube for our kinemetric code analysis, Docker for the containerization of our images for our microservices, JFrog Artifactory to store these images and the crates we produce. Then we, of course, have peer reviewing, Jenkins for our deployments and our functional tests, and finally Kubernetes for our integration and image orchestration. Another subject that comes from our field of activity is secure coding, as we are working on very sensitive subject. And that's why it's really important for us to have rules such as the one wrote by ANSSI, the French National Agency for the Security of Information Systems. And indeed, they wrote the programming rules to develop secure application with Rust. And something equally important is customer approval. And one of our main customers, the DGA, the French Government Defense Procurement and Technology Agency, also works with Rust. And some of their Rust experts already reviewed some of our Rust code. And they also accepted several projects developed in Rust. So to conclude on this section on how we use Rust at La Ruche, one of the great specifications of our domain is that we work on a wide variety of infrastructures. It includes far edge, edge, and cloud, of course, and it is therefore important to be able to code smoothly in as many environments as possible. And as usual, Rust makes it easy first to work with a modern stack in the cloud, with all the existing traits from every tool we use, like protobuf that we use for our data models, or Kafka and NATS, our main tools for the exchange of data between our microservices. And therefore, we can create new services using Rust and easily integrate them with our other services in a cloud project, or for a critical component, we can easily replace them from another language to Rust if needed. And it also makes it easy to work on embedded projects and embedded system, thanks to his crates compatible with NoSTD development. So for those not familiar with NoSTD, it means no standard library. And so using NoSTD can be beneficial in scenarios where minimizing code size, reducing runtime overhead, or working in a constrained environment is crucial. It also to have final control over the dependency and optimize the code for specific use case. And at La Ruche, we use it mainly on PikeOS, a real-time operating system that you talked about before. And so at La Ruche, we aim at converge IT and OT. IT is the information technology, often related to the cloud environments, and OT for operation technology, often related to embedded products on end devices. And therefore, code and developers can make should be reusable between different projects. For example, codecs were written in Rust for critical components in InfraEdge on PikeOS, for example, could easily be used in a microservice in cloud or edge environment using VMs and Kubernetes, as shown in this little infographic.
Okay, so now we know that Rust match La Ruche philosophy, but does it address the issues that lead us to search for a new language? What are the key features of the language and its ecosystem that address the needs we had? So first, Rust is fast. It's one of the reasons we choose it. But other languages are also fast. So how does Rust help us make our software more performant? First, what does fast mean? Benchmarks show that Rust performance are in the same order than performances from C++. We saw in our product that it was faster than Go for equivalent piece of code. Also, unlike Go, there is no garbage collector with Rust. This improves our tail latencies results because there is no resources taken from garbage collection. There is no stop the world. It means that Rust gives us more control over the execution and the memory, for example, when it's read. It's a key feature for us because some systems strongly relies on the timing. High jitters can have a negative effect on them. It also means that we do not spend time trying to fine-tune the garbage collector to gain small performance benefits. Rust is also strongly optimized. It means that we don't need to sacrifice clarity for performance. It also means that we don't need experts spending time on optimization. It was a huge improvement for us coming from Go, where the compiler spent less effort on optimization. And finally, Rust introduced many zero-cost abstraction. We can use high-level abstraction like iteration without losing on the performance side. It helps write fast code that is clear and easy to review, even for a far-edge device. The second reason we had for using a new language was to improve safety and security in our programs. Rust is also known for being safe and secure language, but we already choose Go for its safe and secure benefits, so how do they compare? When we choose Go, we made a simple list of verifications from the language that prevent multiple kinds of errors. Adding Rust to this list, we can see that Rust keeps the same guarantees but brings some more. As we can see, Rust prevents null pointers exception. It makes variable immutable as defaults, and integer overflow are checked. Null pointer exception is an example we care of because we experience that this kind of issues can happen easily in Go. In this example, we see a simple decode function that returns data or an error. And in the Go code, if we fail to properly handle the error, we may use the data variable, which maybe would be a nil value. But with Rust and the result enum, we access the data only if there is no error. So with this rich type system and ownership model, Rust guarantees memory safety without losing on the performance side, as do Go with its garbage collector. It also guarantees thread safety and prevent data race at compile time, which, as we saw earlier, can easily happen with Go. The ownership model, even if it's difficult to work with at the beginning, not only makes the code safer, but it helps developers improve the way they organize their logic. And so it helps architecture complicated software system. Rust also allows for a finer memory management, which may be necessary to better handle where sensitive information are stored. It helps to safely storing this kind of information. All of these features make that using Rust automatically validates part of safety coding rule used in the industry to improve software safety. For example, more than 2 and 3 rules from MIS-RACI coding rules are enforced by Rust. The result is that even developers that don't apply this kind of process from the start, the language already makes them write safer code. We saw that Rust helps us write safe and secure code, but for some projects we may need to go further and have a certified compiler. Lucky for us, Fero System and Adacor are already working on Ferocin, which will provide a qualified Rust compiler. Ferocin will be first qualified for automotive system certification, but other certifications are in mind, which is interesting for us. Okay, so we saw that Rust enables us to write secure and safe code, but we also use a lot of crates. In fact, the Rust ecosystem contains multiple initiatives to improve supply chain security. First, there is a RustSec advisory database that lists vulnerabilities in crates and crates that are not maintained anymore. And there is many tools that help automate the verification of the crates we use. We will see how Cargo Audit, Cargo Deny, and Cargo Vet can help us improve our supply chain security. So first, there is Cargo Audit that helps to detect the vulnerabilities in the crate we use. It lists all the vulnerabilities of the crate listed in the cargo log file. This is important for us to automate this process because we obviously need to check that the crate we use do not bring vulnerabilities, but we also need to analyze the potential vulnerabilities in the product we have delivered for years. Next, there is Cargo Deny. It's useful to check the license of all the crates we use against a list of allowed license we made. Because we deliver proprietary software, we need to ensure that all the crates we use have a compatible license. As always, in the Rust ecosystem, we can see that the tool output a very clear error, and it explains which license is not accepted. We can also use Cargo Deny to ban specific crates or source from waitlist. And finally, one of the most interesting tools for me is Cargo Vet, which helps share dependency audit across organizations. For safety and security reasons, we sometimes need to audit the sources of all the dependency we use. This is a tremendous work to do and to maintain. Cargo Vet allows to share this work between trusted organizations. This organization can be Google, Mozilla, or just different entities of Thales. Audit could be incremental. If an organization audits a specific version of a crate, another organization can audit the incremental change to the next version. Then both of these organizations can benefit of this work without duplication. Audit can also be focused. An organization can produce an audit focused on a particular analysis, for example, the absence of unsafe code in a crate. And finally, it's decentralized. There is a registry that helps finding other audits, but we can directly import audit from the specific organization we trust. So to show how it works, when we add a new dependency or upgrade a dependency in our project, the tool searches if it has already been audited by an organization, and if we approve this organization, the approbation is added to the project. So as we saw, Rust helps us write safe and fast software without compromising on La Ruche philosophy. And to make an after-action review on our adoption, today we now use Rust as a default language for critical components, and we keep using Go for the others. Rust is used from edge to cloud projects, and we are about 20 developers to work with Rust across 4 teams. And to answer our fears about learning difficulties, we saw that it takes about 2 months for a newcomer to be comfortable with Rust. So thank you, and if you have questions, feel free to ask them.
Thank you. You explained you had a significant improvement in performance at some point. What was the explanation? Because Rust is great, but doing 3 times better than C++ means, was there some bottleneck you identified more easily with Rust or something like that?
It was on decoding code where there is a lot of little operation that was not very optimized in Go. So yes, it was from Go to Rust that we see an improvement.
Thank you for your presentation. I have one question regarding your activity domain. Did you find the Rust ecosystem satisfying in terms of cryptographic library or security frameworks?
In fact, we did not have to use a lot of this kind of libraries for now, so can personally answer on this, but maybe my colleague. No.
Thank you for your presentation again. Just you mentioned, let's say, a lot of improvement regarding security. Have you identified some concrete benefits on your test suite, the number of tests you have probably been able to avoid or something like that?
We don't have metrics on that, but we experienced the fact that some errors we made and spent time to analyze and go, and then we saw on Rust that it was not possible. Make us confident on the fact that we win a lot of time using Rust.
Thank you.
What volume of code do you write in Rust? A lot of code or just 10 lines? Or what is the volume that you manage now in La Ruche?
I don't know, some thousand I think, but I can tell.
Million lines or
No, not million.
K lines? Okay.
Thousand.
Thank you for the presentation. I was wondering how your newcomers learn Rust.
So yeah, I'm a bit of a newcomer still, so I can maybe answer that. We do not have a clear process. Like we work with the others in peer programming, for example, to start, and then we start doing a small thing in the projects that need Rust, and we learn like that. There is not a real process for the newcomers learning Rust at La Ruche.
So I can probably add something on that point. Apparently, Thales Academia is going to be resurrected next year, I think, which is, I think, really good. And I hope that we can add a training session on Rust in Thales Academia because, as Paul said, most of people learn Rust in a few weeks, but having a mentor around you, next to you, during 1 week to learn the most complicated stuff about borrowing and memory management, that can really help. If you have that mentor around you for 1 week, it's really, really cool. So having real physical sessions in Thales Academia, that will help. I hope that we will be able to make that happen.
Hi, you mentioned that you work on with Rust on ECE as well. Have you used it on PyCore's native yet?
We just tried it a little bit, and it was working. It was just a proof of work, but it was okay. We exchanged with Cisco on what we were doing, and they'll help us doing it.
So apparently PyCore's has a support for Rust, but mostly core and libutils or something like that. They don't go beyond that for now.
It works only in no STD mode.
Yeah, but that's the beginning.
You guys talk about security and stuff. So I'm a second year from ECE, and I was wondering what kind of security are you guys mentioning? So is it about the behavior of the language, or is it about like memory leaks or something related to that?
It's about preventing all the mistakes we can make. And
so it's more about human mistakes than the language itself, is it?
Yes, but we can't fix humans, so we prefer choosing a better language to solve our issues.
Thank you.
I will add something also. We work on sensitive data, so like Rust can allow us to be more secure on what data can be accessed from our programs and so on. So that's why we chose Rust as a language, as a secure language.
Hi. If you were to tell, what would be your biggest pitfall or biggest pain you had with Rust?
I don't know really, but Yeah, at the beginning, understanding the code, because I didn't start with tutorial and so on, so I was reading the code my colleagues did, and it was a bit hard to read. But specific thing I don't know, and then when you understand, it's not that hard.
So did you try to use async code on some considered difficult task in Rust?
Yes, it was one of the main difficulties I had using async too soon, but when I understood, it worked.
So I have a question for you. Have you tried mixing Rust and C++? And no?
So
a project that mixes both languages.
we delivered Rust as a .so library, but it was another entity of Thales which used it. So I didn't see the code that was using Rust. But it was easy
You did Rust for a project based in C++?
Yes.
So no problem.
And it was pretty easy to build this library.
Did you interface your Rust code with assembly language?
We didn't try that, but I think it's possible.